In the last lesson, we learned how to identify the molar ratios between two substances involved in a chemical reaction. And you were told that you were going to use that ratio in order to convert between those two substances. In other words, we want to make predictions, like how much of a product could we make if I react 5 grams of this reactant? Or maybe I want to make 10 grams of this product, so I have to figure out how much reactant I need. The first step to solving those problems is to be able to convert between the moles of two substances, and that uses the process of dimensional analysis. We should be familiar with dimensional analysis because we have been using this process to convert between grams and moles of substances. But before we get into doing a chemical reaction equation, let's review those steps of dimensional analysis here by solving a gram to mole conversion for helium. So the first step is to read the problem and identify what you're starting with, you're given, and also the unit or the unknown, what we'd like to convert into. How many grams does 15 moles of helium weigh? The given in this problem is 15 moles of helium. The unknown in this problem is grams of helium. That means we have to convert moles of helium to grams of helium. So we need a relationship that links those two units. Remember that this relationship is a definition that never changes. Kind of like how 1 foot is always 12 inches or 1 day is always 24 hours. Just a quick reminder that you will find this relationship on the periodic table. 1 mole of any element is equal to the mass that you see on the periodic table in grams. So 1 mole of helium weighs 4 grams of helium. That relationship will become our conversion factor. Finally, we're going to solve. The first step in solving a problem like this is to write the given with the number and the unit and make it a fraction by putting it over the number 1. Then you're going to multiply it by the relationship, and you're going to set this up as a fraction as well. When you draw your fraction bar, you want to make sure the unit you have as your given, in this case moles of helium, is now on the bottom of the other fraction. This way, moles of helium will cancel because that's the unit we want to get out of. The other unit in the problem, grams of helium, would then go on the top, and notice it will not cancel out with anything. Finally, you will fill in the numbers from the relationship that go with these units. Finally, to solve mathematically, you will multiply across the top, then multiply across the bottom, and finally, you will reduce that fraction and put on the unit that didn't cancel. Then you're going to look at your answer and make sure it makes sense. If I have 15 moles of helium, that means I have more than 1 mole of helium. And if 1 mole of helium weighs 4 grams, then my answer should be more than 4 grams, and it is. 60 is more than 4 grams. And my unknown is grams of helium. That should be the only unit that doesn't cancel out and ends up here, and that is what happened. So I know that I've probably solved this correctly. Now it's time to apply those exact same steps to a stoichiometry problem, where we convert from 1 mole of one substance to another mole of another substance. Keep in mind that you have more information in front of you than the other problem. You have a balanced chemical equation, and there's more information here than you need. Let's think about something for a second. When you were solving the grams to moles problem, you had to look at the periodic table to get the relationship. That periodic table had way more information than you needed to solve this problem. You only needed to know the mass of helium, and so you looked at just the helium block on that periodic table. So, when we go to solve this problem, you're not going to look at all of this information. This balanced chemical equation is what you need to get your relationship. So that means you're only going to look at the moles of the two substances involved, and you can ignore the rest. So let's put this into practice. The first step is to read the problem and find the given amount and its unit or substance and the unknown. What substance do we want to convert into? How many moles of CO2 will be produced if only 1 mole of C2H6 reacts? You are given 1 mole of C2H6 in this problem, and I've also highlighted in the balanced equation so we know to use that number. But remember, the number from the balanced equation is your relationship. Your given comes from the problem, not the balanced equation. The unknown for this problem is how many moles of CO2 will be produced. So I need a relationship that links moles of C2H6 with moles of CO2. I will be using these two substances for my relationship. 2 moles of C2H6 equals 4 moles of CO2. We will ignore the other substances in this reaction because they're not part of the problem. Now we have to solve. The first step in solving is to write the given, the number, and everything in the unit and make it a fraction by putting it over 1. Now we multiply it by the relationship that is also a fraction. Make sure that the given unit that you want to cancel out of is on the bottom of this fraction. And make sure that the unknown unit is on the top. If the two units are on opposite sides of the fraction bar, they cancel. Now, after you have your units in place, you will go to the relationship and fill in the numbers. The number 2 goes with moles of CO2. Oh, I messed that up. Hold on. Let's try that again. The number 4 goes with moles of CO2, and the number 2 goes with moles of C2H6. Always make sure you're double checking. Then what you'll do is multiply across the top, multiply the numbers across the bottom, reduce that mathematically, and then put the unit at the end that did not cancel out. Make sure that your units that you end up with, in this case moles of CO2, matches your unknown, what you want it to solve for. Also make sure that this makes sense, so we know that these ratios are proportional. In my relationship, I see that if I have 2 moles of C2H6, I need twice as many, or 4 moles of CO2. So that should also be true here. If I have 1 mole of C2H6, I should need twice as many, which would be 2 moles of CO2. It looks like this problem was solved correctly. Now it's your turn to pause the video and solve this problem on your own. We want to know how many moles of CO2 will be produced if 3 moles of O2 reacted. Make sure that you're looking at O2 instead of C2H6 for this problem. Pause the video and solve, and then when you unpause the video, the solution will show up. Here's the solution for this problem. Take a moment to pause the video and check your work. If something doesn't look like what you solved, then try to figure out what may have gone wrong. And if you still aren't sure, make sure that you make a note to ask a question during our next class when we review this skill. Here's a similar practice problem. What if you react 0.25 moles of oxygen? How many moles of water will you make? This time we're comparing oxygen and water, so make sure that you're looking at the correct 2 substances. Pause the video and solve this, and when you unpause the video, the solution will pop up. Here's the solution for this last problem. Pause the video and check your work. If something didn't come out right, take a look and see where you may have gone wrong. And if after that you still don't understand what went wrong, make sure you make a note to ask about this question in the next class.